All right, so we are moving on to the second page of our ticket to retake. Number 7 just has us practice going back and forth between exponential form and logarithmic form. We need to make sure we have that down so that we can use that anytime we need it. Like, oh, just switch forms, switch forms. You got exponent form, let's go to log form, and that might make the problem easier to work through, whatever the case may be. All right, so first we have 4 to the third power is equal to 64. So what that looks like in log form is we start out log. Every logarithm has a base, a little subscript that goes down here, and that is the base of your exponent form. 4 is the base, 3 is the exponent, so that 4 is the base of our logarithm. So log base 4. One thing we can think about is all logs are equal to the exponent. So in this case, if the exponent is 3, I know that it's going to be equal to 3. So log base 4 of something, whatever exponent form is equal to, that's what we're taking the log of. So log base 4 is equal to 3. Another kind of way to look at it when you have log form, we're saying that 4 raised to some power is 64. What is that? 4 raised to what power? That's what the 3 is. That's the exponent. All right, so we've got another exponent form. The base is 6. The exponent is -3. So in log form, log, we need our base of 6. We know this is going to be equal to the exponent of -3, and then log base 6 of what? Of that 1 over 216. So I notice sometimes I use parentheses, sometimes I don't, of what we're taking the logarithm of. Um, you know, Sometimes I think I throw in parentheses just to make it more clear. This is a log base 6 of this whole fraction of the 1 over 216. If it's just a single number or a single variable, I'm not always using a parenthesis, but you could always use parentheses just so that you're crystal clear on what you're taking the log of. All right, so our next row, we're given the log form. So when we're given the log form, we want to try to find the base. So here's the log. I don't see any subscript like this 4 or this 6. When they don't write the base in for you, the base is going to be 10. So in log or in exponential form, I know the base is 10. And remember, the log is equal to the exponent. So I know that that 35 is the exponent. So 10 to the 35th power equals whatever we were taking the log of, which is x. So there is exponent form. The next row, well, we might say, well, that's not a log. That's whatever that looks like. This is a lowercase l, and that's an n. That is your natural log. So if the base of your log is e, we talked about the number e on the first page of this review, they're not going to, if your log has a base of e, then we just call it a natural log. So when we say natural log, we're just going to say, oh yeah, that means the base right here that's not written in for you is e. So to go into exponent form, a natural log will always have a base of e, and it works just like the logarithms because natural log is a log. It's just a logarithm with a base of e. It's always equal to the exponent. So I know we're going to say e to the 8th power in exponent form equals whatever we were taking the natural log of, which is 3x. All right, so next we have exponent form 1000 to the 0 power. So the base is 1000, so it's going to be log base 1000 to the power of 0. So I know that this is going to equal the exponent of 0, and then whatever you're taking the log of, whatever it's equal to right there, it's going to go right here. All right, last one. We have a log base 5. So in exponent form, here's the base 5. It's equal to the exponent, so to the 1/2 power is equal to the square root of 5. All right, so there's just kind of toggling between exponent form and log form. So why do we need to know that? Well, that's going to help us with lots of things, especially numbers 8, 9, and 10. So it says solve the equation for x, show your work. So first we want to look at our equation. We have 2 plus log base 5 of x is equal to 3. We got to solve for x, which is right here. We're taking the log of this x, so we can't get to it. You can't get to the thing we're trying to solve for. So part of this process will be if you can't access the thing you need, then we can switch forms. So we are going to end up going to exponent form, but first we're going to get this log term alone. So that 2 out front, we're going to get the 2 to the other side. We'll just subtract 2 from both sides. So we have log base 5 of x is equal to 1. Now to get to that x, we have to switch forms. When we switch forms, we try to find the base of our log. The base is 5. Remember, logs are equal to the exponent, so 5 to the first power is equal to whatever you were taking the log of, which is x. So there we got x alone. So x is equal to 5 to the first power, or just 5. All right, next problem. We have 4 raised to the power of x plus 2 minus 16 equals 60. All right, trying to solve for x, do you see how it's an exponent? Well, I can't get to it because it's up there in the exponent position. So how do we access it? We're going to switch forms. But first, we're going to get this 4 to the raised to the power of x plus 2. We have to get that alone before we go from exponent form to log form. So we've got this plus 16 we have to add to both sides. So 4 to the x plus 2 power is equal to 60 plus 16 is 76. Now if we want to get to x, which is up here, we have to switch forms. We're going to go into log form. So log, we need our base. This is what that 4 is, log base 4 of something equals the exponent, and our exponent is x plus 2, and that's where the 76 goes. Log base 4 of 76 is equal to x plus 2. Now this is a number on your calculator, log base 4 of 76. We could type that in. I tend to wait to type that in at the end. We are trying to solve for x, so we can subtract 2 from both sides. So we got our x alone. X is equal to log base 4 of 76, and then minus 2. All right, so I'm going to grab my calculator, I'm going to type that in. One thing to remember when you use either your log button, now on the graphing calculators, you don't want to use the log button because the log button uses base 10. But we remember how if we go to our math option, and you can scroll down to where you can change the base of your log. So you're going to have to type in, you're going to have to go to the math menu, scroll down so you can get log base 4. And then what it does is it opens up a parenthesis for you. So you're going to type in 76 and you have to close the parenthesis. If you don't close the parenthesis before subtracting 2, you will get an incorrect answer. So when we do this, we get x is equal to 1 point, I'll just round to the nearest hundredth, I guess. 1, 2. The directions didn't tell us. So x is equal to 1.12. And we could plug this x back in right there. 4 to the 1.12 plus 2 power, then subtract 16. It should be about 60. Not exactly because we do have a rounded answer, but we could check that to make sure that we are on track with that answer. All right, number 10. We have to solve for x. Well, x is locked down in this natural log. So we're going to have to switch forms at some point to access the x. But what we want to notice is we're taking the natural log of x minus 5, and that 2 that's out front does have to go to the other side first. The 2 is being multiplied, so we're going to divide both sides by 2. So we have the natural log of x minus 5 is equal to 12.5. All right, now we're in log form. It's natural log form. We're going to switch forms. So we need To go into exponent form, we need the base. Remember, the base of a natural log is e that they don't write in for you. Raised to the power of, natural logs are equal to the exponent, just like logarithms are always equal to the exponent. So e to the 12.5 power is equal to x minus 5. Last step to get x alone, we're going to add 5 to both sides. So we got that x alone, x equals e to the 12.5 power plus 5. And then we just type that in and see what we get. And we do get kind of a big number here, 268,342. I'll say 0.29 rounding to the nearest hundredth. All right, if I were to plug that number in for this x right there, 2 times the natural log of that big number minus 5 should equal 25. All right, so to be honest, I thought that seemed like an unusual number, and I just told you we could plug it in and it should equal 25. So I did pause and double check that on my calculator. I plugged that number in for X and it got me almost exactly 25. Not exact because it is a rounded answer, but like 25 point, a bunch of zeros and then a couple numbers. So very, 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 it's about 25, which is correct. All right, last one for this page. We got Deshawn, who invests $5,000 in a savings account that earns 6% annual interest, compounding continuously. How long will it take to double his money? All right, so they're asking us how long something will take. So that just gives us a heads up. We're going to have to find the time or solve for the time in our problem. Because this is a compounding continuously problem or situation, we have a formula for that. We've got A equals P times E to the RT power. So let's plug in a couple things. We know P is the principal deposit, which is $5,000, times E is just that number on your calculator. R is the interest rate, 0.06 times T, which is what we don't know. And so all of this is going to be equal to something over here. It says, how long will it take to double his money? So doubling 5,000 means we want to know when this is equal to 10,000. Okay, now we have an equation we can solve. I am going to erase those underlines. Okay, so we want to solve for time. Our time is up here in an exponent. So to get that alone, we are going to end up at some point switching forms. But before we do that, we do want to get this e to the 0.06t alone. So we're going to divide both sides by 5,000 to start. All right, 10,000 divided by 5,000 is 2. So we have 2 equals e to the 0.06t. Now to get to the t, we're going to switch forms. This is a base, so we're going to go into log form, but our base is e. Anytime your base is e and you go into log form, you're going to use a natural log. So we're going to use natural log of base e. Remember, it always is equal to the exponent, so 0.06t. So it's a natural log of 2. So we just went from exponent form to log form. We used a natural log because of the base of e in exponent form. Now to get the t alone, we're going to divide both sides by 0.06. There's our t is equal to, and then it's a calculator. What's the natural log of 2 divided by 0.06? When we type that into our calculator, we get 11.55, or I'll just round that up to 11.6 years. That's our time. So it will take Deshaun about 11.6 years for him to double his money if he just puts $5,000 into a savings account and lets it sit there, earning 6% annual interest compounding continuously. In about 11.6 years, he'll have $10,000.